geometry students, in this video we will be studying what a trapezoid is and also characteristics of trapezoids. Your heading for today is trapezoids, lesson 6.6. So please copy that down. Trapezoids, lesson 6.6, and be sure to include today's date. I'll pause a second while you do that. Trapezoids, lesson 6.6, and be sure and include today's date. Now, as we continue on, like normal, let's start off with a definition, okay? You are responsible for this definition, so please take some really good notes and copy this definition in your notes. A trapezoid is a quadrilateral with exactly one pair of parallel sides, okay? I'll pause a second while you copy that in your notes. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Only one pair. It would look something like this. While you guys are copying down that definition, I will give you some examples. This would be a trapezoid. This side here is parallel to this side here. This side here is not parallel to this side here. It has to be a quadrilateral. In other words, it has to have four sides. Here's another example of a quadrilateral. It could look like this. Not the best drawing, but this side here is supposedly parallel to this side here. This side here is not parallel to this side here. You have exactly one pair of parallel sides. So a trapezoid is a quadrilateral with one pair of parallel sides. Alright, let's continue on. Before we go any further, we need to label the different parts of a trapezoid so that we can look at another definition and 5 theorems intelligently. Please take really good notes on this, okay? And make sure you label these parts in your notes and understand what these parts mean, okay? Here we go. Please take really good notes. First of all, please copy this in your notes. Go ahead and draw a trapezoid that looks like this. And then notice the legs would be this side here and this side here. Now, please make note of this in your notes, students. Students get confused every year. They think these are the legs because these are the sides going up and down. So, they think if you take this and you turn it, then now the legs would be here and here, and that is incorrect. Incorrect. The legs are please make note of this, the legs are always the non-parallel sides, always. So I don't care which way your trapezoid is turned, your legs will always be the non-parallel sides. Please make note of that, and please don't forget that. Okay, continuing on. Now, the bases are always the parallel sides. Always. Please make note of that. They are always the parallel sides. Okay? Look, it doesn't matter which way you turn this trapezoid. You can turn it like this. Okay? The bases will still be this side here and this side here. The parallel sides are always the bases. So please make sure you understand that. Okay, I'm going to pause while you get all that squared away in your notes. The legs are the non-parallel sides. The bases are the parallel sides. Okay, now please pay attention to this next part. It can be really confusing. Take some really good notes. Go ahead and number the angles in your trapezoid like this. 1, 2, 3, 4. Go ahead and do always come in pairs of 2. Always. Okay, sorry about that. They always come in pairs of 2. Now, listen to me very carefully. 1 and 2 are not base angles. 3 and 4 are not base angles. 1 and 4 are base angles. And 2 and 3 are base angles. 1 and 3 are not base angles. 2 and 4 are not base angles. Base angles are the angles that run along the parallel side. So here's one of the parallel sides. This angle's at one end, and this angle's at the other end. So they're called, 1 and 4 are called base angles. Here's the other parallel side. At the end of this side is one angle. At the end of the other side is one angle. Those two angles are base angles. Base angles always come in pairs of 2. Do you understand this? I hope that you do. Base angles always come in pairs of 2, and they're always on the corners of the parallel of one parallel side. They're on the corners of one parallel side. Okay? Alright, let's continue on. Please take really good notes on this. Now, having laid a pretty good foundation, let's go ahead and take a look at 5 theorems today. Okay? 5 theorems. And actually, students, before we do that, I did make a mistake. There's one definition I want to go over first before we get to these 5 theorems, and I apologize for forgetting that. Copy this in your notes, please. We need to take a look at this real quick. We talked about what a trapezoid is. Now let's talk about what an isosceles trapezoid is, okay? An isosceles trapezoid. Copy this in your notes, please. You are responsible for this definition. An isosceles trapezoid is a trapezoid with congruent legs. A trapezoid with congruent legs. Not congruent bases, but congruent legs, okay? So, here's an example of an isosceles trapezoid. Not perfect, but you get the idea, okay? First of all, take some really good notes on this. First of all, here's your one pair of parallel sides. Those are called your bases. Here's your legs right here in black. Anytime these legs are congruent, we'll put a mark here and a mark here, or you can use numbers if you want to. We'll say this leg here has a length of 8, and this leg here has a length of 8. Anytime you have a trapezoid in which the legs are congruent, then you have an isosceles trapezoid. Got it? So an isosceles trapezoid is a trapezoid with congruent legs. I'm going to pause while you get caught up, and then we'll continue on. You need to know this. Isosceles trapezoid. You need to know this. Okay, now, having laid a pretty good foundation, let's go ahead and look at 5 theorems. Please copy this theorem in your notes. I'll pause a second while you copy this down, okay? Theorem 6.17. It's called the trapezoid base angle theorem. Trapezoid base angle theorem. And it reads as follows. If a trapezoid is isosceles, then each pair of base angles is congruent. If a trapezoid is isosceles, then each pair of base angles is congruent. Go ahead and copy that down, please. If a trapezoid is isosceles, then each pair of base angles is congruent. Okay, now please take some really good notes on this. Here's what it's saying. If we have an isosceles trapezoid like this, please take some good notes on this, guys. Copy this in your notes. If ABCD is an isosceles trapezoid, then angle A is congruent to angle D, and angle B is congruent to angle C. Okay, got it? That's all that it's saying. So if you have an isosceles trapezoid, then these two angles here are congruent, and these two angles here are congruent. Got it? Okay, so if a trapezoid is isosceles, then each pair of base angles is congruent. Now, you are not responsible, by the way, if I ever go too fast in class. Just have the supervising teacher pause the video and get caught up, okay? You are not responsible to prove this, but let's quickly use common sense and explain why this is true, okay? So just kind of sit back and listen. You know, be respectful. Please don't talk, because remember, guys, I can make you memorize these proofs, and I'm not doing that this time. This proof here is pretty big, so just watch as I do it, okay? And just listen. You don't have to take notes on it. All right. Here's an isosceles trapezoid. This side here is parallel to this side here, so I have a trapezoid, and this side here is congruent to this side here, so I have an isosceles trapezoid, okay? Now, if I have an isosceles trapezoid, which I do, then each pair of base angles is congruent. So using common sense, watch what I'm going to do. I'm going to draw a line straight down that's perpendicular here. Now remember, if these two lines are parallel and this angle here is 90, then this angle here has to be 92. How do I know that? Because if two parallel lines are cut by a transversal, this angle here and this angle here are called consecutive interior angles, and consecutive interior angles are always supplementary. We learned that a long time ago. So I can draw this line here, and I can also draw this line over here. And this is 90, and this is 90. Now again, you're welcome to take notes on this, but you don't have to. You can just listen if you want to. So if this is 90 here, then we know this has to be 90 here. This has to be 90 right here. Now look what I have. Watch this carefully. I have a right triangle here in green. I have a right triangle, okay? And I have a right triangle over here. Now again, the proof is kind of long, but we're going to use common sense. It stands to reason that if this line here is parallel to this line here, then if I draw two lines that are perpendicular, these distances from here to here and here to here have to be the same. And plus I know that because look guys, I've got a parallelogram right here. How do I know I have a parallelogram? Well, I have a four-sided figure in which both sets of opposite angles are congruent, 90 and 90, 90 and 90. So if I have a parallelogram, then I know that I know this side here has to be congruent to this side here. I know this side is 6, and I know this side is 6. And remember, guys, one of the ways to prove that a right triangle is congruent is what? Do you remember? Hypotenuse leg. So look. I have a hypotenuse here congruent to a hypotenuse here, a leg here congruent to a leg here. So that means this angle here has to be congruent to this angle here. And that means this angle here has to be congruent to this angle here. So I'm going to get rid of all this mess now, and we're going to look at the angles, okay? And again, you don't have to take notes on this. I'm not going to make you do this, but I think you can see the proof would have been pretty tough, okay? So I know this angle is congruent to this angle. I know this angle is congruent to this angle. I know this angle here is congruent to this angle here, over here. So I know this angle is congruent to this angle. I just proved that. And I know this is 90, and this is 90. That means this whole angle here is congruent to this angle here. So in a way, I really didn't prove this theorem, but using common sense, I explained why this is true. So if a trapezoid is isosceles, then each pair of base angles is congruent. Please don't forget that theorem, okay? Moving on. Okay, on theorem 6.18, please take a second. Let me pause and say this again. You're not responsible for any of that stuff that I just did, but I'm trying to cut you a little slack on these proofs because they're really difficult. So please be respectful, be quiet, listen. You don't have to take notes on that part, but make sure you're listening. Okay, let's take notes on this, please. Go ahead and copy this in your notes. Theorem 6.18. Copy this down, please. The trapezoid diagonals theorem. The trapezoid diagonals theorem. The trapezoid diagonals theorem. If a trapezoid is is isosceles, then its diagonals are congruent. If a trapezoid is isosceles, then its diagonals are congruent. Okay, let's take a look at this. Once again, if a trapezoid is isosceles, then its diagonals are congruent. Please take really good notes on this, okay? If ABCD is an isosceles trapezoid, then AC is congruent to BD. Here's AC. Here's BD. Okay? Let's look at it again. Please take really good notes on this. If a trapezoid is isosceles, then its diagonals are congruent. You need to know this theorem, understand it, and copy this down, okay? I'll give you a couple more seconds to get caught up, then we're going to move on. Okay, here we go. Now, you will prove this theorem in question number 33 when you do the homework from lesson 6.6, so I will not go into detail as to why this theorem is true. However, you are responsible for this theorem, so I could very well give it to you on a test. Okay? And you're going to do it in problem number 33 in your homework. And you are responsible for this theorem. I think it's about 6 steps. It's pretty small, okay? Alright, let's continue on. Theorem 619. Please copy this in your notes, students. Theorem 619. Copy this in your notes. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. If a trapezoid has one pair, just one pair of congruent base angles, then it is an isosceles trapezoid. I'll pause a second while you copy this down. Okay, here we go. Now, students, let's take a look at this. Let me draw a trapezoid real quick. Wow, that's a really good trapezoid. Please take some notes on this, students. I do want you to take notes on this. Please copy this down. A, B, C, D, and I'm going to call this congruent to this, okay? So if I have a trapezoid and A is congruent to D, angle A is congruent to angle D, then I have an isosceles trapezoid. Or, listen to me, students, if this angle here was congruent to this angle here, then I would have an isosceles trapezoid. All that you have to have is one pair, only one pair of base angles that are congruent, and you have an isosceles trapezoid. Please make note of this, okay? So from now on, you know that if you have a trapezoid and one pair of base angles is congruent, then it is an isosceles trapezoid. Okay? Alright, moving on. Now, again, be thankful that I'm not making you be responsible for this proof. It's pretty long. But please, I don't want you to take notes, so just forget that. please listen very well as I explain to you why this theorem is accurate. Now, if you want to take notes, that's totally fine, but you do not have to. So here we go. Please take some really good notes. Alright, now, if I have a trapezoid, so here's my trapezoid with one pair of congruent angles, so here's my pair of congruent angles. Then I have an isosceles trapezoid. Now watch how this makes common sense, okay guys? Watch this. I'm going to draw another line here like I did before. I'm going to draw a line here like I did before, okay? And I know this is a right angle here. And so's this. And so's this. So's this. And this. And this. Okay? Now, I know, just by common sense, well, I know I have a parallel. This is a parallelogram right here. I know that's a parallelogram right there because opposite angles are congruent. So I know this side here is congruent to this side here. So students, please look what I have. I have angle, angle, side of one triangle congruent to angle, angle, side of another triangle. Thus, these two triangles are congruent. These triangles right here. This triangle in green is congruent to this triangle in green. Now, if those two triangles are congruent, then because of C, P, C, T, C, I know this side here is congruent to this side here. Now, students, think about it. As soon as I prove that this side right here is congruent to this side here, then I have what right away? I have an isosceles trapezoid, because an isosceles trapezoid is a trapezoid that has congruent legs. So there, I did it. Okay? So it's really not that difficult. I'm not making you responsible for this, but that is how I know Theorem 619 is correct. Okay? Alright, moving on. Here we go. 2 more theorems to go. So hang in there, and we're almost done. Alright? 2 more theorems to go. Alright, here we go. Theorem 620. Please copy this in your notes. You're responsible for it. If a trapezoid has congruent diagonals, then it is an isosceles trapezoid. Okay, copy that down. If a trapezoid has congruent diagonals, then it is an isosceles trapezoid. So please take some really good notes, okay? Here we go. Okay, now here's what I have. If trapezoid A, B, C, D. So if I have a trapezoid and I have AC is congruent to BD, then I know that A, B, C, D is a what? Isosceles trapezoid. So we've learned 2 ways now, students, to prove that a trapezoid is isosceles. If you have one pair of congruent base angles, if a trapezoid, has one pair of congruent base angles, then it's isosceles. And if a trapezoid has congruent diagonals, then it's isosceles. Okay? So make sure you understand this. If a trapezoid has congruent diagonals, then you have an isosceles trapezoid, which then means this side here is congruent to this side here. Alright? Now, I'm going to explain this to you, but I want you to watch and not really try to take notes. Just sit back and listen and watch, okay? This is a really, really difficult proof. I'm just going to explain it to you, okay? Please watch carefully. I'm going to draw a line down here. Actually, I'm going to draw a red triangle here. Let's see. Come up, over, down here. And let's see. Yeah, it's not right again. Hold on a second. is congruent to this red triangle here, okay? Just sit back and watch and see if this makes sense, okay? Now here's my red triangle right here. Here's my green triangle right here. Now remember, we know this side here is congruent to this side here because this middle square here thing is a parallelogram. I've showed you that before, okay? And we know the diagonals are congruent. That's given to us if a trapezoid has congruent diagonals. So this is congruent to this. And we know we have a right angle here, right here, and we know we have a right angle here. Here's a right angle, here's a right angle. So I have hypotenuse leg of one right triangle congruent to hypotenuse leg of another right triangle. So I know these two triangles are congruent. Thus, if these two triangles are congruent, then this angle here, which is right here, is congruent to this angle here, which is right here. Now I told you this is tough. It's not easy to see, okay? So just watch, okay? You don't have to understand this or get it right. Just watch. So now I know that this angle here is congruent to this angle here. Now, next I'm going to prove that this big red triangle here is congruent to this green triangle here. And when I do that, then I can state that this side here is congruent to this side here by CPCTC. So I'm going to prove these two triangles are congruent. So here's my green triangle right here. Okay, it's the same triangle as here. Here's my red triangle right here. I'm going to pull it over here. Alright, now don't forget, students, we already know that this angle here, which is right here, is congruent to this angle here, which is here. Okay? And this diagonal here is congruent to this diagonal here, which is this line here and this line here, because that's given to us. Alright? And we know this side here is congruent to this side here because the two triangles share this side right here. They share a common side. So I have this triangle here congruent to this triangle here by side, angle, side. So as soon as I state that, then I know for sure this side here is congruent to this side here, which means this side here is congruent to this side here, which means, of course, that I have an isosceles trapezoid, okay? And again, if you try to do these in a two-column proof, I think this proof was about 13 steps long, 13 or 14 steps, so I'm not making you do that, but I'm still explaining these to you so you can see them, okay? Alright, now for those one or two students who are still awake, let's continue on. Lastly, Theorem 6.21. However, before we tackle Theorem 6.21, we have to learn one definition, and you are responsible for this definition, so please write it down. You need to know this, okay? Mid-segment of a trapezoid. Mid-segment of a trapezoid. What is the mid-segment of a trapezoid? I'm glad you asked. It is the segment that connects the midpoints of the legs. The segment that connects the midpoints of the legs. So let's say I have a trapezoid that looks like this. Now it doesn't have to be isosceles. It can be any trapezoid at all, okay? So this side here is parallel to this side here. I'm going to find the midpoint of this leg right here. It's about right here. I'm going to find the midpoint of this leg. It's about right here. I'm going to connect those two. Okay? And we're going to call this segment AB. AB is the mid-segment. Got it? AB is the mid-segment because it connected the midpoints of the legs. So I know this segment here is congruent to this segment here. And I know this segment here is congruent to this segment here because this is the midpoint of this whole side over here, and this is the midpoint or the middle of this whole side over here. Got it? So you need to know what a mid-segment of a trapezoid is. It's the segment that connects the midpoints of the bases. No, not the bases, of the legs. Please don't forget that, okay? I'm going to pause a second while some of you get caught up in your notes, then we'll continue on in just a minute. last theorem, 6.21. This is called the mid-segment theorem of trapezoids, or for trapezoids. Copy this down, please. I'll give you a second to do that. The mid-segment of a trapezoid. Notice, it does not have to be isosceles. It does not have to be isosceles. It can be, doesn't have to be. The mid-segment of a trapezoid is parallel to each base. And its length, the mid-segment's length, is half the sum of the lengths of the bases. Now I'm going to explain this for you in a second, okay? The mid-segment of a trapezoid is parallel to each base, and its length is half the sum of the lengths of the bases. Alright, now take some really good notes, please. Here's a trapezoid, okay? Here's the mid-segment right here. How do I know that? Because I've got a mark here, 2 here, and 2 here, okay? We know this is parallel to this because I have a trapezoid, okay? Well, the first thing you know about your mid-segment is it's parallel to the 2 other legs, or 2 other bases. So, there we go. All 3 of these lines are parallel. Secondly, if this length up here was 8, and this length down here is 12, add those 2 together, it's 20, and divide it by 2, and this length here is going to be 10. Let me go over that again. That's what this means right here. Half the sum of the lengths of the bases. Okay? So, if I know one base is 8 and the other base is 12, and I know this is the mid-segment, I can add those 2 together. And then whatever I get, divide it by 2. So 8 plus 12 is 20. And 20 divided by 2 is 10. So this mid-segment is 10. Okay? There it is. Now, I want to show, well, actually, let me erase this. So with that in mind, let me throw a couple problems that I'd like you to write in your notes. If I gave you a trapezoid like this, copy this in your notes, please, guys. And I said you have a mid-segment right here. And I told you this length up here was 4. And this length down here was 7. And I said find the length of the mid-segment. Go ahead and do that quickly on your own. You would say 4 plus 7 equals 11. Then take your 11, divide it by 2, and you would get 5.5. So there you go. You found the length of the mid-segment. It's 5.5, okay? Now I've got a question for you. Can you find the length of one of the missing bases? If I told you that 4 is one of your bases, and the mid-segment is, I don't know, let's see, 6. Can you find this other base? Guys, you should be able to take the mid-segment 6, multiply it by 2, and then you know this segment here and this segment here has to add up to 12. Let me say that again to you. If I give you 2 bases, if I give you a base of 4 and a base of 6, you add them together and divide by 2, and the mid-segment would be 5. If I give you 1 base and 1 mid-segment, then take the mid-segment, multiply it by 2, that gives you 12. And then you know this base up here and this base down here have to add up to 12, so the other base would have to be 8. And then, by the way, guys, you can check your work. Add your 2 bases together. What's 4 plus 8? 12. Divided by 2, and what do you get? 6. So make sure you understand this theorem really, really well, okay? I'm not going to get to the proof of this or explanation. We really have to finish up and go on, okay? So here we go. Let's tie together what we learned today. This is mandatory note-taking. I do want you to take notes on this, so here we go. Number 1, an isosceles trapezoid has what? Congruent base angles. and congruent diagonals. Copy that down, please. Well, we know also one more thing. We know by definition it has what also? I should have included this. Congruent what? Legs. That's just by the definition of an isosceles trapezoid. Copy this down, please. An isosceles trapezoid has congruent base angles, congruent diagonals, congruent legs. Okay? Copy that down, please. I'm just trying to tie everything together at the end of this lesson. A trapezoid is isosceles if. Okay, here we go. A trapezoid is isosceles if one pair of base angles is congruent, diagonals are congruent, and there's another way too I should have written down, if the legs are congruent. But of course that's just the definition of an isosceles trapezoid, but either way we'll still write that down. So a trapezoid is isosceles if one pair of base angles is congruent, only one pair, or the diagonals are congruent, or the legs are congruent. Please copy this down. You need to know this, okay? Go home tonight and study this if you're able to. Lastly, a mid-segment is half the sum of the bases. A mid-segment is half the sum of the bases. So there you go. This is what we learned today. And make sure you understand this. Go over it. Go over the theorems and make sure you understand this material, okay? Hopefully this has been a help to you. If you have any questions, don't hesitate.